Hello everyone, this is Yang Liu from Hong Kong Baptist University. I'm sorry for not coming in person today, so I used a video presentation instead. In this presentation, I will introduce our group's work on towards learning emotional subspace. Our system is composed of two steps. The first is subspace learning, which aims to map the original data to the low-dimensional subspace. And the second step is to predict on the learned subspace. In step 1, we propose the EPE, which aims to learn the subspace where the emotion information and manifold structure are well preserved. This is designed for arousal and valence. And the second method is BDE, which is designed for fear. The motivation is that in fear prediction, one might be more interested in the fear class than the non-fear one. In step 2, we're going to make predictions on arousal, valence, and fear. For the prediction of arousal and valence, we formulated it as a real-value regression problem and used SVR to solve it. And for the fear prediction, we formulated it as a binary classification problem and used SVC to solve it. In experiment, we have both development set and the test set, and we use 11 types of features provided by the task for learning. First of all, we learn the transformation matrix W by using the proposed method on the development set. And then we utilize the learned W to map both the development set and the test set data onto the subspace. And after that, we train the SVC and SVR by using the development set in the subspace. And finally, we employ the trained SVC and SVR models to predict the arousal, valence, and fear of the test data in the same subspace. We have submitted 4 runs for each task. The only difference is the dimensionality of the subspace in each run. It is 4, 5, 9, and 10 for run 1, run 2, run 3, and run 4, respectively. Here is the result. First of all, we show the result of arousal prediction in table 1. We find that the run 1 performs the best, while run 4 performs the worst. And moreover, the performance drops when the dimensionality of subspace increases, which indicates that the arousal information may be embedded in a very low-dimensional subspace, and thus increasing the dimensionality of subspace may have a negative effect in terms of prediction of the induced arousal. And table 2 is the result of valence prediction. It didn't show a clear implication in the optimality of valence prediction with respect to the dimensionality of the learned subspace, which may indicate that we have not yet discovered the optimal dimension of the subspace for valence, and further investigation is needed. And in table 3, we show the result of fear prediction. And obviously, the performance of our method is unsatisfactory. The reason might be that high imbalance between fear class and non-fear class makes the traditional learning mechanism inefficient, even though we have already made some efforts in modeling the class imbalance during the subspace learning. Based on the experimental result and some observations, we're going to investigate our further work on this task from the following 2 ways. First, we plan to explore how to build a joint learning mechanism for both arousal and valence, because these two are closely related to each other. And secondly, we're going to investigate more effective ways to model the class imbalance in subspace learning as well as the subsequent classification, especially for the extremely imbalanced cases. That's all of my presentation. If you have any questions, you can email me. Thank you very much.